Welcome back. Today we will be talking about the vectors in the plane. So when we are talking about the vectors is a physical quantity that indicates both magnitude and direction. So when we are talking about magnitude in a very simple language, it is nothing but the distance and in what direction we are covering that distance. So for example, when we say southwest at 20 kilometers per hour, it basically indicates southwest as the direction and 20 kilometers defines the magnitude of the vector, right? On the other hand, we have something called scalar or constant. So there is always a confusion between the vectors and the scalar and constant. So when we are talking about the scalar or the constant, scalar or constant implies only the physical quantity. That means only the magnitude. Direction is not involved. So that is the biggest comparison between vectors and scalar. Now, how to represent the vectors? Vectors are represented as a lower case boldface. So in many textbooks or online, wherever you want to see, vectors are always the lowercase. Don't write the uppercase, and they are always bold face. So vector, we say vector V is equal to PQ, and if you can see the hat on the top of PQ, it is not the arrow, it is only a half arrow, right? And that is how you denote the vector. So P is your initial and Q is your terminal. Just like on the airport, when you enter the airport, that is your initial point. Your target is to reach to the terminal so that you can board the plane. So first with the initial and then with the terminal point. So magnitude is nothing but the distance and initial and terminal. So the half arrow on the top of PQ defines the direction. You can also see there are two lines. That two lines defines the magnitude. So when it says when the vector v is written in between these two lines, that implies we are talking about the distance or magnitude. This is not the absolute value. In absolute value, we have one line on either side. In this case, we have two lines on either sides. So two vectors, on the other hand, we can say the two vectors are the same or equivalent when they have the same distance and the same direction. So green arrow indicates that the vectors are going in the same direction and they have the same magnitude. Another key component, we talked about the initial and the terminal. So this, in the standard position, when we are talking about the initial, we are talking about that it is at the origin, right? And the terminal point is our destination. So V1 and V2. Now, V1 and V2, this will be defined as the vector V1 and V2 are the components of the vector V. We don't use the regular parentheses to define the vector. We use the, the crocodile mouth to represent the vector greater than and the less than sign. Now, P and Q, they are the distance, right? So we are saying PQ is the distance and we are using the distance formula to find the distance of the vector v or the magnitude of vector v. So keeping that thing in mind, let's take one example and it will be a little bit more clear about the theory. So in this case, the initial point is given as -3, -5, and the terminal is given at 5 and 1. So they are asking about the component form and the magnitude. Magnitude, again, it is nothing but the distance. So I label them initial as the x1, y1 and terminal as x2, y2. So my component, that means the x component, difference between the x component will be v1. Difference between the y component will be v2. The same as the coordinate plane, we write x followed by y. So v1 is nothing but the x and v2 is nothing but the y. So distance, the difference between the x2 minus x1 is v1 and v2 minus v1 y1 is the v2 is y2 minus y1. And I can apply this in the distance formula. Remember, this is just a distance formula. Distance formula says x2 minus x1 whole squared plus y2 minus y1 whole squared and everything inside the radical. So 8 and 6 are the component 8 is x2 minus x1. 6 is y2 minus y1. I just have to use the distance formula. And because we are talking about the vector, we are talking about magnitude. So use the symbol of the magnitude, and then v squared, which is x2 minus x1 squared, v2 squared, which is y2 minus y1 squared. So 8 squared plus 6 squared, and if you compute it, you will get the magnitude. So don't get confused with the theoretical aspect. When you apply the theory in the practical equations and the question, it is just a distance. Just remember that x comes first before y. So initial will come first, the component of the initial and the terminal, the first component will be x and then followed by y. Now you have learned about the scalar multiplication in geometry, the dilation when you did the scalar multiplication. So when k is positive, that means the scalar multiplication, the direction will be the same. When k is negative, then the direction will be opposite. So when we say u plus v, we are just adding the x component. So x components together, add x and then add y. When we say u minus v, we are subtracting it. So these are the properties of the vectors addition and the scalar multiplication. So u plus v is nothing but v plus u. Anything added to any number, a zero is added to any number, will be a number itself. And the c in this case represents your scalar multiplication, or because c is the constant. Let's take this example. We have vector u and vector v. In the first case, they are asking for, let's add them. So I will add the x components together and the y components together. So 3 plus 1 is 4, and then 2 plus 4 is 6. You got u plus v. In question number B, they are asking for u minus v. So we are subtracting them. And in part C, they want you to multiply the vector u with 2 first. So that will give you 2 and 8, and vector v by 3. So 9 and 4. And when you subtract them, you are getting negative 7 and 2. As you can see, we have graphed it. When the vectors are added together, right? So we have vector u and we have u plus v. Vector v will follow the same direction as vector u when you are adding them. When you are trying to graph for u minus v, vector v will not follow the same direction. So I will show you the graph for u minus v. So this is how it will look like. So the first graph is for u plus v. So you can see we have vector u, and then we have vector u plus v as 4, 6, and vector v follow along. But in the second graph, we have u minus v. So we are going for vector u, which is 1 and 4, vector u minus v. But vector v is going in the opposite direction because it is a subtraction. So that is how you can compare the two graphs, and just by looking at the graphs, you can understand whether it's a subtraction or a addition of the two vectors. In the third one, we have 2u. So 2u is going in one direction. We have 2u minus 3v, but because it is a subtraction, v is going in the opposite direction. So the subtraction will take it in the opposite direction. So if the question is given, identify whether it is addition, subtraction, or what. Just by looking at the diagram, you can identify. So what you can do, first plot the first vector, and then the sum or the subtraction of the two vectors, and then you can form the triangle. So when you are graphing it, it will always form a triangular scenarios. Let's take another concept that is called a unit vector. To represent a unit vector, we have a vector v, and we divide the vector v by its magnitude, right? So vector divided by its magnitude will give you the unit vector. In this example, we have they are asking you find a unit vector in the direction. So vector v is given as 6, negative 1, and we need to verify as well. So first line of action will be vector is given, let's find the magnitude of the vector. And because the vector is given, that means 6 is v1 and negative 1 is v2. So I just have to put it in the radical and square it. So magnitude of vector v with the proper notation will give you radical of 6 squared plus radical plus negative 1 squared. That will give you the magnitude. So magnitude is radical 37. I just have to put it in the unit vector format. So vector u is equal to unit vector, which is vector v divided by the magnitude of v. And I can separate them actually. So we can say 6 over radical 37 and negative 1 over radical 37 will be your unit vector. But our work is not done here because the question asks for to verify. Now this is my new components. These are the components of vector u. Let's take the magnitude of vector u and see what will happen. So to check, let's find the magnitude of u. So we have v1 as 6 over radical 37, which will be squared, plus negative 1 over radical 37, which will be squared again. If you simplify it, you are getting 36 over 37 plus 1 over 37, which is nothing but radical of 1, which is nothing but 1. So it is giving you the answer 1. That means our answer is verified. Now, there is something more about the vectors that is called the standard unit vector. We did unit vector. So unit vectors are represented in I and j. If you remember, we did the x-intercept and the y-intercept. The concept is the same. So when we are talking about I, there is no y component. So that is 1 minus 1 comma 0. When we are talking about j, there is no x component, or x component is 0. So 0 comma 1. In this case, I is not the imaginary number. It is not radical of negative 1. It is just a standard unit vector. So if we have a vector v, which has a component v1 and v2, it can be represented in the standard vector. So I can say vector v, component v1 times 1 comma 0. And v2 will go with 0 comma 1 because v2 represents y and v1 represents x, right? So the vector sum can be written as v1i plus v2j. v1 is horizontal component and v2 is a vertical component. And this kind of notation is called linear combination of I and j. So since v1 is the horizontal component, it will go with 1 comma 0. And v2 is the vertical component, it will go with 0 comma 1 because vertical implies that we are just talking about the y-axis. Horizontal implies that we are just talking about the horizontal axis. So let's take one example. So initial and the terminal are given. What they are asking for, linear combination. So whenever they ask for linear combination, they are asking for I and j format, right? So linear combination of the standard unit vector I and j. So we have the initial and the terminal. So we are starting with negative 2, 6 and negative 8 thirds. That is my direction. Now, to write in the linear combination format, what is the component form of it? Let's find the component form. So can I say initial is negative 2 comma 6 and the terminal is negative 8 comma 3. So I rewrote it. So can I say x2 minus x1? So negative 8 minus minus 2. And y2 minus y1, 6 minus 3. That will give you the component, right? So x2 minus x1, y2 minus y1. That will give you negative 6 and negative 3. It is always advisable to label your points because when you label the points, it is easier to compute those and the error will be reduced. So now I have the component forms. Let's write in the linear combination. So negative 6 I and negative 3 j. That's it. So whenever they talk about the linear combination, we are including I and j to represent our vector. Let's include the directional angle now. So we have the initial point and the terminal, but there is an angle that is being formed while approaching to the terminal point. So that is called the directional angle. Remember, x-axis is nothing, it represents the cos theta, or cos theta goes with the x-axis and the sine theta goes with the y-axis. So I can rearrange the linear combination I and j. So we can say cos theta I plus sine theta j uh, when we are talking about the directional angle and we need to calculate the angle theta, right? So vector v ai plus bj is your linear combination and we need to find the angle. So I can say ai plus bj is vector v, which is nothing but the magnitude times cos theta I plus sine theta j. So that is your first point. Second is use tangent theta to calculate b over a, that will give you a theta, and we can use arc tangent, which you have done in geometry. So let's take one example. So they are asking you to find the directional angle. Directional angle implies we have to include cos theta and sine theta. So this is in the format of ai and bj. So ai and bj, that means a and b will help us to calculate tangent, right? So this is not step one. Step one is to write ai plus bj, but I'm just writing it as step one. So tangent theta is equal to sine theta over cos theta, and sine is nothing but b, and cos is nothing but a. So with this, I can compute my tangent theta. So we will get -4 and -7. And one important thing, both a and b, they are negative. So they are negative. Now think about it. In which quadrant both x and y are negative? Right? Both x and y are negative in quadrant 3. So we need to be very, very careful because we need to identify in which quadrant our terminal point will lie, right? So it will be in quadrant 3. Now we have tangent theta is 4 over 7. Now how to calculate the theta? We can take inverse. So if I take inverse, the answer is already given on the left hand side, but how to compute that answer? So can I take arc tangent? So arc tangent of 4 over 7 will give you theta. If you use a calculator, that will give you your answer will be theta will be 29.748 degree. Now 29.748 degree, because it's the third quadrant and we are starting from the initial point, that theta is only a part of it. That means below the x-axis. So basically what we are talking about the total angle. The total angle will be 180 degree plus 29.7448. So let's say the total angle is theta prime. So theta prime will be 180 degree plus this angle that we just calculated, 29.7448, because it is in the third quadrant. In the third quadrant, it is more than 180 degree. So the theta prime, the total angle is 209.74 degrees. So whenever they ask for the directional angle, we have to involve the trig. We have to invoke trig. And tangent, by invoking tangent, we are getting the theta, right? So these are some of the questions that you can see in this unit. After that, we will try one word problem. Now read the word problem slowly. So what they are asking for, find the component form of the vector that represents the velocity of the airplane descending at a speed of 150 miles. So descending means it is going down. So 150 miles per hour. So magnitude is given as 150 miles. And the angle is given as 20 degrees. So that means we are talking about the directional angle. So vector V, magnitude of V times cos theta I plus sine theta J, that will be your vector V. So we are given magnitude of V as 150 degrees and the directional angle. We don't have to calculate the directional angle. Directional angle is already given as 20 degrees. We just have to compute it and put it in the equation to find the vector V. Vector V, if I find the vector V, I will get the component of it, right? So we have magnitude of V and we are writing cos 20 degrees I plus sine 20 degrees, 200 degrees, not 20. Oh, it is 200 degrees. Now why it is 20 degrees? Because 30 degrees is below the x-axis. So the x-axis will make it 180, 180 plus 20 degrees, the directional angle, total combined. Remember, we did theta prime. So theta prime, in this case, theta is considered as theta prime. So 180 plus 20 degrees, that is 200 degrees. And that is why if you compute in your calculator, you will get all of these values and multiply with 150. So we are getting the component form. So the component form is negative 140.96, and the another component is negative 51.30. So remember, because it was descending, it was below the x-axis. So above the x-axis is 180 and the angle included, which is 20. So 180 plus 20, that is 200 degrees. How to check? Let's find the magnitude. If we are getting the magnitude as the given magnitude, so given magnitude was 150. So if these two components, while computing, gives you approximately 150, that means these components are correct. The vector is correct. So when we calculated, we got approximately 150 degrees. So take this chapter slow and watch it again to get